Bivariate analysis and distribution review, refreshing our memory of all the things that we did essentially last year, covering statistics and probability. Starting off with correlation. Remember, correlation was the relationship between two pieces of data, okay? Whether you were trying to see if there was a relationship between your GPA and the number of hours that you got to sleep. You can see there's a correlation or relationship between those two pieces. It was found using your calculator. There is a by hand way to find correlation. If you are doing an IA that deals with correlation, maybe doing it by hand would be something good to add to that personal engagement. I have a video of how you can do it by hand online. But it was for test purposes found using your calculator. If the value of R, and let me fix this a little bit, if the absolute value of R was in between 0 and 0.25, that meant that the correlation was very weak. If the value of R, the absolute value of R was in between 0.25 and 0.5, it was considered a weak correlation. 0.5 and 0.75, moderate, and 0.75 and 1, it was strong. Of course, if it equaled 1, that meant that it was a perfect correlation. And if it was 0, there is no correlation. All right. To find that, you would go to your calculator, you would click Stat and Edit. That's where you would go to enter in your data, of course, Stat, Edit. And then to actually get your correlation coefficient, you would go back to Stat, over to Calc, and option 4, which was Lin-Reg. Not only would you get your linear regression equation, but you also got your correlation. You always want to make sure that your X listens in L1, your Y listens in L2, but there is no frequency list. Okay, if you do, you're going to end up getting incorrect answers, but only your X variable, GPA, your Y variable, hours of sleep, should go in X list and Y list. So when you calculate, R would be there. Okay, R would be there. Now, when you guys sit in your at the end of this year to take your exam, your calculator's memory is going to be cleared, which means that your correlation coefficient will not show up. The default setting turns off your diagnostic when the calculator is reset. So make sure that you make a note of this, write it down. I'll also remind you the day of the test is that you have to make sure that you turn your diagnostic on. For you guys who have your fancier calculators, if you press the mode button, you can see down here in the blue options, it says Stat Diagnostic. That will be actually off when you sit for your to take your test, your calculator portion of the test. So you'll go to mode, Stat Diagnostic should be on, okay? If you have an older calculator, then what you're gonna have to do is you're gonna have to press the second button and then the 0 button, which takes you down to the catalog. And then you'll actually have to go down to the Ds. Instead of scrolling till you get to D, you can press the X to the -1 button and it automatically jumps you down to the Ds. And then you can just scroll down until it says diagnostic on, and you'll click enter to turn it on. All right. But again, anytime you reset your calculator, change out the batteries, it defaults back to its factory settings. With scatter plots, okay? Outside of correlation, there was also linear regression and line of best fit. If you have to draw your line of best fit by hand, you need to find the mean point. You need to find the mean of your X's and the mean of your Y's, okay? You'll find the mean of your X's and the mean of your Y's. And then you would plot that point. How you would plot it, of course, you would make a point, you would circle it, and then you would label it. A lot of times you can just label it with an M. However, in the problem, if it tells you to label it with a P, then you'll need to label it with a P. But you'll find your mean point, your X and your Y, plot that point, circle it, label it with an M. Then when you actually draw your line of best fit by hand or by eye, you draw the line so the data is equally spread amongst the line. In other words, half of your data is above the line, half of your data is below the line. It must have a Y-intercept. I've seen on several mark schemes that if your line of best fit doesn't cross the y-axis, you lose points there. So make sure that one, the line goes through the mean point, half your data is above the line, half your data is below the line, and it has a y-intercept. Of course, when you're graphing, like a graph yourself, please make sure you label your axes, not just with the scale, but with what the axes actually are. That also goes for your IAs. Any of y'all doing charts, or not charts, graphs or anything like that, please make sure your X and Y axes are labeled. The regression line, it is done with the calculator. Again, if you want a few more extra points, potentially, if you are doing a regression line for your IA, I do have a video on how you can do it by hand on my YouTube page, but for test purposes, you do it with your calculator. Of course, you go to stat, you go over to calc in option 4, making sure you type in your X list and your Y list, and you get your equation, Y equals MX plus B, or in this case, AX plus B. And then you fill in. Regression lines are only found if there is a moderate or strong relationship between your data. Regression lines are only found when there is a strong or moderate correlation between your data. And remember, regression lines are used to make predictions. They're used to make predictions within your data values. Within your data values. So what does that mean? If your X's range goes from 50 to 100, then you can only, well, not only, but if your X value falls within that range, then it's a valid claim, okay? But if it lies outside of your range, let's say they wanted you to plug in an X value of 120 and find whatever the Y value is. You can do it, you can find the Y value, but it will be considered an extrapolation because that value lies outside of your range. So then would it be valid? Is it reliable? No, it's not, because it's outside of the range that the regression line was created for. The regression line was created for the data values that lie between 50 and 100. Anything outside of that is not reliable because you don't know what could happen after 100. If it does lie within the range, then it's called an interpolation. Okay, so outside the range, extrapolation, inside, interpolation. So let's take a look at this example. This one I'm going to do with you, and I think the next one I'm doing with you, but you will try some on your own. The following table shows the sales, Y, millions of dollars of a company, X years after it opens. The relationship between your variables is modeled by the regression line Y equals AX plus B. Find the value A and B, write down the value R, and hence estimate the sales in millions of dollars after 7 years. So for this particular problem, we go into our list. Okay, I make sure I clear out my data. Remember, go up to L1, L2, press clear and enter, and I type in my data. Hopefully you guys are doing this as well, so you can get that muscle memory back of how to do this in case you have forgotten. Put my X's into L1, my Y's into L2. I want to make sure that my columns are even. Make sure I don't miss any entries. If I have 5 entries in L1, I need to have 5 entries in L2. Otherwise, I'm going to have an error message. For me personally, I like to quit out of my program so I don't have any issues. Second mode quits me out of that. Stat, calc, option 4. X list in L1, Y list in L2. Frequency list is clear. I go to calculate, and there is my regression line as well as my correlation coefficient. So A is 4.8, B is 1.2. And R would be what rounded to 3 significant figures? Very good. So to estimate my sales in millions of dollars after 7 years, what am I plugging into my equation? And for what variable? Say a little louder. I'm plugging in X. What number am I plugging in for X? 7. Somebody do this for me, please. 4.8 times 7 plus 1.2. There you go. So 34.8 millions of dollars is what we would have after 7 years. Is this the interpolation or extrapolation? It is an inter, because as you can see, 7 would technically fall right here, and it makes sense. This is a strong correlation because it's close to 1. You can see that as the years increase, so do the sales in dollars. So yes, 34.8 would actually fall between 30 and 36. It is within the data range. So it would be an interpolation. So the following table shows the average weights for given heights in a population of men. The relationship between the variables is modeled by a regression equation, y equals ax plus b. You have to write down the value of a and b. Somebody give me a.
0.486.
0.486. Somebody give me b.
Negative 12.41.
Very good. And so that gives me my equation of y equals 0.486x minus 12.41. Then somebody give me what is the estimated weight of a man whose height is 172 centimeters.
71.
Say that again, Vegas.
7.182.
Okay. In kilograms, yes, of course, you can always round that to 3 significant figures. It did end because both A and B ended as well. So you can provide that, or I can round it to 3 significant figures, which would be what? 71.2. Now I have to write down the correlation coefficient. Somebody different?
997.
Yes? Okay. All right, so I need 2. And even Bowles, which 2 of the following describes the correlation between the variables? How would I describe 0.997? Somebody different?
Strong.
It's strong.
And positive.
And positive. Very good. Random variables. Okay, this is where we get into our distributions, because pretty much that was the bivariate analysis part of statistics. Okay, it was correlation, linear regression. Okay. For random variables is when we get into our distribution. The main thing kind to remember about your random variables was your probability distribution table, which is what you see on this particular slide. Capital P of capital X equals lowercase x represents the probability of some random variable X for every little x, which could be any value, 1, 2, 3, 4, 0, whatever. A probability distribution is a table that represents all of the different outcomes for your random variable and their respective probabilities. Okay, so in this example that I pulled, the different X values that you can have are 0, 1, 2, 3, and 4. I mean, that could represent, having in a pack of 4 batteries, 0 of them being defective, 1 of them being defective, 2 of them being defective, and so on and so forth. Then you have your respective probabilities underneath them. What's the likelihood of those probabilities actually happening? The thing about a probability distribution table is that all of these values, all of these probabilities should add up to equal what? Should add up to equal 1 if it truly is a probability distribution, okay? Sometimes the probabilities won't add up to equal 1, and in those respective cases, it's not a probability distribution, and you have to tackle it a different way. Expectation, represented with the capital E of X, capital X. So the expectation of our random value also meant the mean of our particular random variable, okay? It is found, and I pulled this literally from our old random variable notes when we first did this, okay? To find expectation or expected value, you take each of your X values and multiply them by their respective probabilities. And after you multiply them, you add the whole lot together, okay? So each of the X values times their probability, then sum them up, you would get your mean. There was a talk of, say that your probability distribution represented the outcomes of a game. Well, if expected value is equal to 0, if the mean was equal to 0, then the game was considered to be fair. Okay, so they ever asked you, was the game fair? Should you recommend playing this game? The only time you should ever recommend playing the game is if the game is fair. So then you will want your expected value to equal 0. This first example is on me, the next one's on you. So this one's also a non-calculator type of problem. It says the faces of a fair six-sided die are numbered 2, 4, 4, 4, 6, and 6. Let X be the discrete random variable that models the sum of scores obtained when 2 such dice are rolled. Complete the probability distribution table for X and then find the expected value of X. Well, this is a fair six-sided die that has these different numbers. And then my random variable is supposed to represent the sum obtained between the two. For me to visually see this or to get this, I am going to make a sample space. We talked about sample spaces the other day when we were reviewing basic probability, but essentially it represents all the different outcomes of a particular event. And in this case, I'm rolling 2 die. Okay, this is die number 1, and then this is dice number 2. I need another 6. Thank you. Okay, so if I roll a 2 on one and 2 on the other, what's my sum? 4. If I roll a 4 and then a 2, my sum is? If I roll a 6 and a 2, so then 2 and 4 would be 6. A 4 and a 4 would be a 6 and a 4 would be so then 6 and a 4 would be 10. A 6 and a 6 would be. So this is helpful to me because now I can actually see what the lowercase x value should be. The lowercase x values represents the sum of me rolling these 2 die. What are the outcomes? What are my sums that I can get? And that's exactly why there's 5 open spaces for this blank table, okay? Now, what's my total number of outcomes? $36, okay? And so what's the probability of you rolling a sum that's a 4? 1 out of 36. The sample space also gives me that visual so I can just count how many times the sum actually happens instead of trying to go off it from straight memory. Okay, what about 6? 6 out of 36, which reduces, of course. For the sake, no, not even gonna say that. How many times does 8 show up? 11? 13? Does that reduce? No, it doesn't. How many times does 10 show up? Was that reduced down to be online?
1/3.
How many times does 12 show up?
4 times.
And that reduces down to be?
1/9.
So I can either put it in red or I can put it in green. Probably for the test, I would probably have used the green option, but I would have left the red option as well. Because since I have to find expected value and this is not calculator, I have to multiply each of my x values by my probability and add them up. So I need a common denominator anyway, right? So I'm going to multiply all of my x values by my respective probabilities, and then I'm going to sum them up. So this is going to be 4 over 36 plus 36 over 36 plus 8 times 13 is 104 over 36 plus 120 over 36 plus 48 over 36. So when I sum up all of my numerators without my calculator, somebody double check behind me. Oh, that's what I got. So it'll be 312 out of 36. Does that go in evenly? It doesn't? Are you using your calculator? Let's reduce this though. Let's reduce this. It's divisible by 2, so that's 1.
You can take 12 out of it and it would be 26 over 3.
Ooh, yes, thank you. You said 26 over 3?
Yeah.
Wonderful. So then that would be my expected value. Simple as that. Okay. This one's on you. So a discrete random variable x has the following probability distribution. It's given to you as a table. Using what you know of probability distribution, you are able to find the value of k. What did you guys get for k?
0.25.
Say it again.
0.25.
0.25. That's exactly what you should get. Remember, if you add all of these up and set it equal to 1, you are able to solve for k. This is the calculator problem. So you could have easily used the graphing feature, plug the left side into y1, the right side into y2, found the intersection, and then you would have seen that it would have been 0.25. Let me hear from somebody different. Now it says write down the probability that capital X is equal to 2. That's essentially asking what's the probability that X is equal to 2.
0.025.
0.025. It say write down, so it involves little work. Very little, because all I do is I plug in 0.25 in for K and actually divide it by 10. Okay? So I get 0.025. Then for part C, it does say the probability that X is equal to 2, the line, vertical line where X is greater than 0. Remember that vertical line represents conditional probability. So to help you out, remember that's the probability of the intersection between the two divided by the probability of the condition, which is always the part that follows the vertical bar. So what did you guys give for an answer?
.0476.
And how did you get that?
I did .025 over 1 minus .475.
Very good. It says the probability that X is greater than 0. Once you find X, all you have to do is, once you find K, all you have to do is plug it in. These are all of your probabilities that are greater than 0. That is your denominator, 1 minus 0.475. What's that called when you subtract like that, instead of adding up everything I just boxed in pink?
Complement.
It's the complement, yes. And then of course, the intersection between X is equal to 2 and X is greater than 0. Out of all of those values that are boxed in pink, you want the one that actually is equal to 2. Binomial distribution was also part of the distribution. This was used with discrete data, unlike normal distribution, which we'll cover after this, which is used for continuous data. What's the difference between discrete and continuous?
Discrete is counted and continuous is measured.
It is. It is. So for discrete data, we use binomial distribution. This is used also when you have a fixed number of trials with a probability of success that is independent of each trial. Okay? The probability of something happening is independent of the probability that something very similar, the exact same thing is going to happen again. So like you shooting an arrow to hit a bullseye. Okay? That'll be example of binomial distribution. What you see on the board in orange, literally screenshot from when we took these notes back last year of how you go about finding a binomial distribution. Okay? The probability of your discrete variable, capital X, and some particular outcome, which is R, is equal to N choose R. You see that notation with binomial theorem, hence why this is binomial distribution, very similar. N choose R, your number of trials divided by however many outcomes you're looking for, times the probability of success, raise that number of outcomes, times 1 minus that probability of success, raised to your number of trials minus your respective outcome. Okay? So again, N is your fixed number of trials. Your probability of success is P, and R represents essentially, your value, your respective value. That's really all you need to know. Now, a factory makes toys. The probability that a toy is defective is 0.08. A random sample of 50 toys is tested. With these different distribution problems, you have to determine which one is it. This one's binomial because 1, it has a fixed number of trials. What is going to be N in this problem? A little louder. It's going to be 50 because I have a sample of 50 toys that I'm going to test, so that's my N. Do I have a probability of success that's independent of each trial or each toy?
Would it be 0.8 or it's a complement since you're asking about success?
It's actually going to be just the 0.8 because here, when we look at like the different problems it's asking us about the fact that the toy is defective. So defective technically is our success, hence the air quotation marks that I don't know if y'all saw it, but yeah. So even though it's the probability of success, it is the probability of us selecting a defective toy. So that is our P. and it's independent each time. I pick up toy number 1, it has a 0.08 probability of being defective. I pick up the second toy, it's the exact same thing, so they're independent of each other. We're asked to find the expected number of defective toys. Expected number. Expectation. We find expectation by doing what? Doesn't change depending on the distribution. How do I find expected value?
X value times its probability.
X value times its probability, or in this case, my N times my P. If I have 50 toys in the sample and I'm trying to figure out how many are defective, I just multiply the two together. Just like if I'm a 75% free throw shooter and I shoot 100 free throws, the problem I'm expected to make 75 of them. So what's 0.08 times 50?
4.
It's 4?
Yes.
Okay. 4 toys. Now we're going to find the probability that there is at least one defective toy in the sample. At least one means I'm trying to figure out if there's 1 toy, 2 toys, 3 toys, 4, 5, 6, 7, 8, 9, 10, all the way up to 50. I essentially have to find every single one of those probabilities from 1 all the way up to 50. Or I can find the probability of there being 0 that are defective and then doing 1 minus that. And that would be the easier way. So the formula says N, choose R. N is 50, R is how many I'm looking for. That's 0 defective toys. My probability of a toy being defective is 0.08. I'm going to raise that to the R power, which is 0. Then I'm going to multiply that by 1 minus P, which is 0.92, raised to the N minus R, which would be 50. Very similar to binomial theorem. Remember, your exponents have to add up to equal your N. Okay. And that's what I type into my calculator. Who remembers where to find this notation? You already know what that value is. Math, PROB, option 3, NCR. NCR. So 50 is my N, 0 is my R. For some of you guys, you might actually have to type the number first, then do math, PROB. Option 3. So some of y'all might actually have to do 50 math, PROB, option 3. So then that way it can pop up or generate. Of course, anything choose 0 is always 1. Anything raised to the 0 power is 1. And then of course I got 0.92 raised to the 50th power. I'm going to subtract that from 1. So 1 minus 0.92 to the 50th power will give me the probability of me selecting at least one defective toy. This is the work. This is the method. This is how you can get your marks. By showing the formula, plugging into the formula, even indicating that this is a binomial distribution. Even by saying that this random variable is a binomial distribution where N is 50 and my probability of success is 0.08 can even get me method points there. Of course, the work that's associated with it gives me the method points as well in case I get the wrong thing. For C, it says, given that there's at least one defective toy, trigger word, what does that mean? Conditional probability. So given that at least one toy is defective in the sample, find the probability that there are at most 3 defective toys. So at most would be less than or equal to 3. That's essentially what I'm looking for. I'm looking for the probability that at most 3 toys are defective, given that at least 1 toy is defective. So conditional probability says that I need the intersection between x is less than or equal to 3 and that is greater than or equal to 1. What numbers are those? What's the intersection between less than or equal to 3 and greater than or equal to 1? 1, 2, and 3. So I'm looking for the probability that x is equal to 1, plus the probability that x is equal to 2, plus the probability that x is equal to 3, and that's going to be my numerator. Then I'm going to divide it by the answer I got in the previous part, because that's the probability that x is greater than 1. Is everybody still following me?
Yes.
So how do I find the probability that is equal to 1, 2, and 3? Well, that's 50, choose 1, 0.08 to the first power, 0.92 to the 49th power, plus 50, choose 2, 0.08 to the second power, 0.92 to the 48th power, plus 50, choose 3, 0.08 to the third power, 0.92 to the 47th power. And I add all those up. That's going to be my numerator. Then I'm going to divide it by the answer that's still sitting in my calculator. So don't use any rounded answers. We have to use them for future parts. Find my numerator, please. So my numerator all typed into my calculator. I got 0.4098 and some change as my numerator. That is the probability that it'll equal 1, 2, or 3 defective batteries. I'm going to divide that number by the 0.984 number from part B to get the probability, given that there's at least 1 defective toy in the sample, that there are at most 3 defective toys. So the previous answer divided by this answer, and that is my final answer. Questions? I also showed you how to do this in your calculator. Okay, this is the by hand way. This is how you get your method points, everything. Of course, you can use your calculator to get these answers, but it doesn't hurt to at least show parts of this, okay? Such as you actually calculating the complement, you recognizing that it's conditional probability, and you know exactly what values you're finding. Actually, any one of these 3 lines would be acceptable for method points for part C, okay? How do we do this into our calculator? We go to second bars. That's where all of your distributions were. Second bars, that's where all your distributions were. And you would go to either option A or option B, depending on the problem. Binomial PDF was for an exact value. Probability distribution function, 1 specific value. So you would use binomial PDF for part B. Because I was looking for exactly 0 to be defective, and then of course I had to do the complement. So if I go to binomial PDF for part B, my number of trials is 50. My probability is 0.08 that they'll be defective, and my X value was 0. So then I would paste that. Then I'll have to do 1 minus that answer to get my actual answer, which we got by hand. So that is correct. Binomial CDF was a cumulative distribution function. So that means when you're looking at a range of values, okay? So, well, actually, it's kind of hard because you had to do the intersection. And so since we were only doing 1, 2, and 3, not 0, We actually probably wouldn't use binomial CDF, but let me show you real quick. Binomial CDF, those are for your ranges. You can only do the values that are less than a particular X value. So if I did want to figure out what my numerator was, I would do an X value of 3. That would give me the probability of 3, 2, 1, and 0. If I chose the next value of 3, it gives me all the values that are less than that particular X value. So this is giving me 0, 1, 2, and 3. I already know the probability of it being 0 was back up here. So if I take that answer and subtract it from the probability of getting exactly 0, that's exactly what my numerator was. So binomial CDF are for your intervals, if anything. So try this one on your own. Let me reset it. In a large university, the population that a student is left-handed is 0.08. A sample of 150 students is randomly selected from the university. Let K be the expected number of left-handed students in the sample. You have to find K, then find the probability that exactly K students are left-handed, and then find the probability that fewer than K students are left-handed. What was the value of K? The number of, go ahead.
I wanted to answer before someone else did because it was easy.
Mhm.
Eli, okay.
Anyone, either Brock or Eli, anyone.
It's 12.
It is 12. We find that by multiplying 150 by
That wasn't very nice, Brock.
108.
I'm sorry, I had to take it.
So 12 students. Okay, hey, that's 2 marks right there. That's 2 marks. Let's try to get all 6. Hence, find the probability that exactly 12 students are left-handed.
Was it 0.881?
Confirm or deny?
I don't think so.
Okay.
Probably wasn't then.
I think it was 0.119.
Okay, so how did you get that?
I just did binomial PDF.
This one was a binomial PDF. Now, on your paper, you do not put binomial PDF with the fillings. That's calculator notation that is frowned upon. You will not get any method points that way. Do not write that, okay? Instead, it is a binomial PDF because you're looking for exactly 12 students, so you can write this. Or let's say, for like if you got the wrong probability, you know, if Eli had put this on his paper, he could still get a method point here, okay? Now, whether or not he did, that's another story. Or even writing out the full formula, indicating that you know, again, that this is a binomial distribution, like so. Or even this indicates that it's a binomial. Any one of these could suffice as a method point in case you got the wrong value. But yes, in our calculator, second bars, binomial PDF, 150 trials, probability of success, and our X value. Of course, if you get the wrong X value, then there's no hope. Okay, no hope. So your random variable is a binomial distribution with 150 trials, the probability of success of 0.08. Now for B double I, I'm looking for the probability to have fewer than 12 students. What would I write to get my method points on my paper before I go to my calculator. Less than 12? Okay. Or I could put less than or equal to 11. Because I'm not actually considering exactly 12 students, I'm considering fewer than 12 students. And I'm glad that you actually said that, because when I go into my calculator online, under my X value, am I typing 12 or am I typing 11?
Typing in 11 would give you what you need, but couldn't you also plug in 12 and then subtract what you get from part BI?
That is, yes, that would be the only way that that would work. If you did plug in 12, you just have to make sure you subtract your answer from BI, okay? And am I using CDF or PDF here? CDF, because I'm looking for a range. I'm looking for a range. I'm gonna do 11. Did you guys get this? Questions on binomial distribution?
It's more with rounding, but say that it hadn't been an even number for the expected value and it had been like 12.6 or something. Would we round up or down? Because they're students, so you can't have like 0.6 of a student, but I always get confused with the rounding.
On that one, you would have gone to 12. If it was like 12.4, it would have gone to 12, or even if it was 12.6, you still would have gone to 12. Even if it's 12.9, you would still go to 12 because you can't make up for that 10th of a person. However, I've never seen an expected value question where you actually had to use that answer in the future, not be a whole number. Okay, now I have seen expected value in the sense of mean being asked, and then in that case, you don't round because you're only finding like the mean in that case. Something that you do need to be aware of with binomial distribution, not just how to use the formula, but also again, that expected value is found by multiplying n times p, also known as your mean, which we've done several times. And you also need to remember that variance is equal to n times p times 1 minus p. So essentially your number of trials times your probability of success times your probability of failure, okay? And then standard deviation is what? It is the square root of variance. So don't forget about that, because it could ask you for the standard deviation or the variance of a particular situation. Through to the end. Normal distribution is used with continuous data. Of course, you had your bell curve. Please make sure that if you ever have to draw the normal distribution yourself, that is asymptotic to an x-axis, that you label your x-axis with whatever the unit is. Remember that your mean is smack dab in the middle. And then you have 1, 2, and 3 standard deviations on both sides of the mean. Remember that the mean does split your data, your 100% data, into half. So you have 50% to the left of your mean and 50% to the right of your mean. One standard deviation was about 68% of your data. 2 standard deviations was about 95% of your data. And 3 standard deviations was about 99.7% of your data, okay? That is helpful. If it ever asks you, if it's within 1 standard deviation of the mean, 2 standard deviations of the mean, you know roughly about what percentage you're looking at, okay? But the main one for sure is that the mean splits your data equally in half. Don't forget about standard normal distribution though. You guys had to actually worry about this. This is what happens when maybe you're not given the mean or not given the standard deviation, okay? You would use the formula Z equals X minus mean over standard deviation. I pulled that straight from your reference booklet, so that is given to you in your reference booklet. This is helpful, like I said, to find means and standard deviations of other situations. And I know it says on here that the mean is 0 and the standard deviation is 1. Like I said, that's on a standard normal distribution curve, okay, where you automatically assume that your mean is 0. You can use the different probabilities with a standard normal distribution to help you identify what is the mean or the standard deviation in a specific problem, okay? You can find that by using the inverse norm option on your calculator to find the respective Z value, which is down here. It's like along your x-axis. So then that way you can plug it in to help you find your mean. And when I work through an example, you'll see how we use that to do problems like that. So I know you probably don't remember how to do this, so I figured I'd pick one of those as one that I do together with you. Here are all your different calculator features. We will press second bars just like before. So then that way we can get to our distribution options. Normal distribution was at the top. We always use CDF, never PDF. CDF is for cumulative, and we are dealing with continuous data that spans out over a range. Normal CDF is used when you have probabilities. Inverse norm is used when you're trying to find an X value. Students always forget that. Normal CDF, probability. Inverse norm, an X value. And by X value, I mean you're given that the probability is 75% and you're trying to figure out what that X value is that gets you 75%. That's what I mean. Okay? These are what the different screens look like once you type it, once you click normal CDF. Remember, lower and upper stood for your bounds. So if I wanted to figure out a probability that is less than 20, what will my lower bound be? Who remembers? It does. When you go here and you click it for the first time, it does pop up -1. I suggest doing -9e to the 99. Why -9? Because you're trying to get a really, really, really essentially small number or a really large negative number. So that's basically saying -9 times 10 to the 99th power. Okay. This is the normal setup for normal CDF. I don't know why, but -9e, you get that by pressing second comma. Second comma produces the E, or you can always say times 10 raised to the 99th power. Okay. What will my upper bound be? It will be 20, and then my mean and standard deviation would be whatever it is in the problem. For inverse norm, as you guys notice, this is a newer calculator. This right here, this picture came from my old calculator. In my old calculator, I wasn't able to have the option of picking what side of probability I was given. But when I go to inverse norm now, I have one of the more fancier ones, which lets me tell the calculator which tail I want to pick. This is an example of a left tail. This will be an example of a right tail. For those who do not have that tail option, you have got to remember that your calculator can only do probabilities that are to the left of an X value. It automatically defaults to the left. So if your calculator is old school, like my old calculator was, you always have to do the probability that's to the left of your X value. So if they told you that this probability was 30% or 0.30, what would I actually type in for my area? 0.70 because your calculator doesn't allow you to select left tail and right tail. For the fancy one that I have now, I would be able to type in 0.30 and I would be able to tell the calculator, okay, I want the right shaded area. But for everybody else who does not have that feature, you have to type in 0.70 and then your mean and standard deviation and then go to paste. All right, let's look at these two real quick. The price per kilograms of tomatoes in euros sold in various markets in a city can be found to be normally distributed with a mean of 3.22 and a standard deviation of 0.84. That's always will let you know that you're dealing with a normal distribution over anything else. It says find the price that is 2 standard deviations above the mean. If you recall, 2 standard deviations. They're looking for this particular value. I have to add 2 standard deviations to the mean. So 0.322 plus 0.84 plus 0.84. That is exactly what this value is. Okay? Because it's mean, this one is your mean plus 1 standard deviation. This value is your mean plus 2 standard deviations. Okay? The word for that. And then of course you would plug in. At the final probability that the price of a kilogram of tomatoes chosen at random lies will be between 2 and 3 euros. Oh wait, it's price, not grams. My mistake. So am I going to use normal CDF or inverse norm? For part B. I'm using normal CDF because it's asking me to find a probability. Now, I don't write normal CDF, lower, upper. I don't write that into my paper. I show the normal distribution curve with the mean at 3.2, and then I show where 2 lies and I show where 3 lies on the graph, and I shade that area. That's how I get my method points. It was the diagrams, not the calculator notation. Because you're showing the grader that I'm looking for that area underneath the curve between 2 and 3, and I recognize that 3 is less than 3.22. So now you can go into your calculator, do normal CDF. What's my lower bound? 2. My upper. My mean is 3.22. My standard deviation is 0.84. I do not write that in my calculator, on my paper. That stays in my calculator, nowhere else. Do I make myself clear? I draw the diagram if I want method points. And that is my probability. C says to stimulate reasonable pricing, a city offers a free permit to the seller whose price of a kilogram of tomatoes is the lowest 20%. The lowest 20%. So what's the highest price the seller can charge and still receive a free permit? Is that normal CDF or inverse norm? It's inverse norm because you're given a probability, the lowest 20%. And I'm looking for that X value, I'm looking for that price. Let me be proper and label all the diagrams I drew. For this one, what am I going to plug into inverse norm for the area? I am going to do 0.2. I don't have to do 0.8 because that is the area to the left. Because it said less than, correct? Lowest, yes. My mean is 0.322. Standard deviation is 0.84. Unfortunately, I got to tell my calculator to go to the left. And that's my X value. A price of 2.51 euros. Questions? The weights of fish in a lake are normally distributed with a mean of 760 and a standard deviation of sigma. It is known that 78.87% of the fish weigh between 705 grams and 815 grams. This is one of the ones I was talking about, where I do not know what my standard deviation is. But I am going to set up this normal distribution curve where I indicate 705 and 815, and the area underneath is equal to what? Now, real quick, 705 is how far away from 760? How far is 815 away from 760? 55. So they're equally away from the mean, which means I can answer part B, I, and double I. It says write down the standardized value for 815 grams. This is when you go into your calculator and you do inverse norm with the mean of 0 and standard deviation of 1. Why is that? Because what we know is that we're trying to figure out where this value corresponds on a standard normal distribution curve. So when we go in to our calculator and we go to inverse norm, for the area, I need to essentially represent all of the area that is to be left of that value. And I'm using left because the majority of us have the calculator that doesn't have the tail feature. Since this is equally away from the mean, just like 705 is equally away from the mean, what is the area underneath the curve that I've shaded in pink? What is that value? If both of these are the same distance away from the mean, how can I figure out this last little bit of area right here, or essentially the whole area? And how did you get that? Exactly. Well, actually, it will be a total of 50.
Well, yeah. It's not at one point you're doing
But you are right. Since they are both the same distance away, you can split that 78.87 in half. And that will take care of from the mean to one of your standard deviations. And since the mean splits the rest of it in half, that's 50% that's to the left of the mean already. So if I add, actually hold on, 78.87 divided by 2, that 39.435 is this part right here. So when I add that to 50, I have the entire area underneath the curve that I need so that I can find my standardized value for 815. So that's going to be 0.89435. I'm not going to round that. I'm going to leave my mean as 0, my standard deviation as 1. So that is my standardized z-score, 1.25. That is what A15 corresponds to. That is the same z-value that I need, so then that way I'm able to find my standard deviation using the formula x minus mean over standard deviation. My z-score is that 1.2499 number. My x value is 815, and my mean is 760. I use this formula to find my standard deviation. What is my standard deviation? 44? Did you use the exact value? Did you use the rounded? So if you use the exact value, it should be 44.0. So I gotta put that point on. Questions on using the z-score to help us figure out missing standard deviations. I would do the same thing if I was missing the mean. The time taken for students to finish a task is normally distributed with a mean of mu and a standard deviation of sigma. It's found that 6% of students take less than 7 minutes to complete a task and 75% take less than 22 minutes. So how does that break down in a normal distribution curve? Because I gotta find my mean and my standard deviation. Well, whatever the mean is, I know that 6% of students take less than 7 minutes. And I know that 75% take less than 22 minutes. I know that 22 is on this side because 75% is more than 50%. So it's always important that when you do your normal distribution curves, you place the values where they're supposed to be, either to the left or to the right of the mean. Doesn't matter how far, as long as it's to the left or to the right. So this essentially means that in order for me to find my mean and my standard deviation, I have to use the z-score, the whole inverse norm thing, twice. Once to find the z-score for 7, and then another time to find the z-score for 22. Okay? So again, since all these represents the area to the left, I don't have to worry about it if I had an old school calculator, but I go to second bars, inverse norm. I'm gonna do the one for 7 first. So I'm gonna use 0.06, mean is 0, standard deviation is 1. And that's gonna be the corresponding z value for 7. I'm gonna write down a few places. I'm going to do the exact same thing for a z-score of 22. I know my probability underneath the curve is 75%. Mean and standard deviation stay the same. And that's my z-score for 22. There's a reason why I'm putting a few decimal places, because I don't know my mean nor my standard deviation. So essentially what I have is negative 1.55477 is equal to 7 minus mean over standard deviation, and 0.674897 is equal to 22 minus my mean over my standard deviation. I'm using the z-score formula to help me find my 2 variables. I have 2 equations, 2 variables. How do I solve this? Substitution or elimination. It's a system of equations, because essentially I can rewrite both of these as in this one, sigma 7 minus mean. If I multiply both sides by sigma, right? If I turn this, negate it, I can cancel out my means. And then there's my system. This is 15, and this would be equal to the sum of these two values. Divide both sides, and my sigma is equal to 6.73. Now, even though I didn't use the full exact values for my z-scores, I had enough decimal places that it's not going to affect that third significant figure when I actually calculate it. So my sigma is 6.73, and then I will plug back into one of my original equations to find my mean. Okay, so I'm going to use that second one because it's already positive. I'm going to multiply it by 9 rounded. I'm trying to get my closest to what my mean could potentially be, and I have to multiply it by -1. So then my mean was 17.5. All I did to get 17.5 was plug it back into this equation. And I solved for mu. These are a little bit more involved, but there you go.